So we are going to keep graphing these. The only difference is today that we're going to bring in inverses with it. So if you grabbed a calculator, I see most of you did, go ahead and type in the cubic function graph, okay, which is y equals x cubed. What? You did what? You spilled on your math homework?
No.
Is it a linear roughness?
No. Fail. Okay, type it in. What is my starting point for x cubed? What number? 0, 0. Very good. Now, if you don't know how to type that in, look, you just do x and then up to the 3. Okay, just like that. Y equals x up to the 3. Okay? Then hit graph. Okay, we see our shape that we've been looking at this whole time. Okay, it looks normal. Okay, I'm going to go into my table, and remember, I want my starting point to be in the center. Okay, so if it's 0, 0, I need to scroll to put 0, 0 in the middle. And then I'm going to write 2 points above it, 2 points below it. Okay? So I'm going to write these 5 middle points onto my chart. So 0, 0, and then I'm going to graph it. 1, 1, and then I'm going to graph it right here. Okay, then 2 goes with what in your chart? 8. Very good. So 2, 8 is here. Now remember, that's one half of the graph. Now I need to do the other half. And remember, it should make like a squiggly shape. Negative 1, and then negative 2, negative 8. So then I'm going to graph negative 1, negative 2, negative 8. Okay, and so there's my graph. You can see it makes kind of like a little squiggly shape. Okay, domain and range are x all real numbers, y all real numbers, just like yesterday. Okay, what does this mean?
You switch
Yes, okay, what's the word? It starts with I.
inverse.
Inverse. Okay, to find the inverse, we already did this with quadratics. You switch the ordered pairs.
Negative 8.
So negative 8, negative 2 is the first one. And then notice that on these three, since the x's and y's are the same, when I flip the points around, it actually stays to be identical. Okay, and then this one will be 8, 2. I'm just going to put these are the same. Okay? Or you can just rewrite them. That's fine, yeah. So negative 8, negative 2 is way over here. Then these 3 points in the middle I keep because they're the same. And then 8, 2 is way over here. Now, I want you to watch me connect the dots and then do it on your paper so that you don't get confused. Okay, your first curve, I'm going to zoom in on it. Okay, your first curve is going to be from here, curved up. That side is going to curve down. So it's just sideways, perfect. And now remember that that's always true of inverses, right? That diagonal line should cut it perfectly in half. And, you know, mine is in highlighter, so it's a little thick. But you can see that it kind of makes like a little 8 in the middle. Okay? That would be the inverse graph. Now, what do you notice about the domain and range of that squiggle?
It is the same side.
Yeah, they're both all real numbers, right? Because you got one side pointed up, you got one side pointed down. One's headed backwards, one's headed forward. Okay? So let's answer the 3 little questions here looking at the graph. First question, what do the parent function and the inverse have in common? Okay? You already said it earlier, the graphs are the same, it's just what? Flipped. So they have the same shape. Okay, yes. Now do you remember the word yesterday? What do we call it? Rotational symmetry. They have a rotational symmetry. And what that means is that if you were to spin the graph halfway around, it would look exactly the same as what you already have. Okay? Now, how are they different? One is sideways. Okay, now instead of writing sideways, I'm going to put it's reflected across the diagonal. Okay, so they're the exact same shape. One of them is just reflected to be sideways. Okay? And then question number 3, if the original graph is x cubed, how do you undo a cubed?
Cube root.
Yep. So right here, put y equals cubic root x. Now, I want you to think about just for a second, that makes sense, right? A squared and a square root, they're partners. A cube and a cube root, it makes sense that they're partners. Okay, but here's the parent graph. Okay, you'd put your dot at 0, and then you'd curve up on one side, down on the other side. That's the cubic root graph. Okay? So the cubic root, the cube kind of like squiggles up, the cubic root squiggles sideways. But they have basically the exact same shape, just one's to the side. Okay, so take a look at that first example. Okay, we're going to graph it, so look right here. What will my start point be? -2, -5, perfect. This should be familiar from yesterday if you understood the video. So -2, -5 is here. And then I'm going to draw my shape. I'm going to curve to the right on one side, to the left on the other side. Because that's the shape of your cubic root graph. It goes up to the right and then down to the left. Okay, now we're going to find the inverse. Remember, that's what this means, is inverse. Okay, so we did this with square roots. Now we're going to do it with cubics. So the first thing you do is you switch the x and the y, and then you're going to switch the sides. Yep. So it's going to be, this is the same as a y equals, so now it's an x equals. And then instead of an x plus 2, now it's a y plus 2. Okay, so I switch the letters, then I switch the sides. So all of this junk over here is going to get to come first. X is going to come second. So I'm going to have y plus 2 cubed minus 5 equals x. Yep, it's very similar to what we did with squareds and square roots. What do I do first? Can't cube root first.
-5.
Yep, and then cubic root will be my next step. So on the right side, on the left side these guys cross out, but then on the right side I just have an x plus 5 left over. Okay, on the left side I have y plus 2 cubed. Now you can touch this 2 because it's inside the cube. You have to get rid of the outside first. So this is where you're going to cubic root and cubic root. And the only difference between a square root and a cubic root is you put a little 3 in the elbow. Okay? And then these guys here cancel out. So the 3 and the cubic root are gone. Now it's just a y plus 2. I can get rid of the parentheses. And then how am I going to get rid of that plus 2?
You do it at -2.
Good. Minus 2, minus 2. So I have y equals cubic root x plus 5 minus 2. I'm going to rewrite it, but I guess you don't really have to. Up to you. Okay, so let's do our starting point. Okay, notice down here it says my rotational symmetry point for F inverse. Okay, you're looking at this number, -5 and -2. Okay, and now look at these two guys. What are they? They're partners, right? They're just backwards. And so then now I'm going to graph my new point. I'll do this one in highlighter so that you can tell which one's which. So -5, -2 is back here. And then remember that, look at this shape that we drew up here. The top part should be curved up. The bottom part should be curved down. So my top part should be curved up. My bottom part should be curved
Because it's
down.
on the y-axis.
Uh-huh. And then do you see your symmetry around that diagonal? Okay, yeah. All right, turn the page. Okay, next one, take a look at it. How are we going to shift our graph on the next example? Okay, it's an x cubed plus 2. Do I go left or up? Up. How do I know? Yeah, because it's in the back. That's an up 2. So go up 2 right here. That would be 0, 2 for my ordered pair. And then I'm going to go up and down. And it doesn't have to look perfect. Okay, then we're going to do our inverse. Remember, that's what the -1 means here. And for my inverse, I have to switch it to x equals and then y cubed plus 2. So I have to switch the letters, then I'm going to switch the sides. What? Oh. Yes, really only the solving is new for these. And then all the inverse stuff we already covered with the square roots. So how would I get rid of the plus 2? Okay, now I'm going to be a little lazy here. I'm just going to put an arrow and then make it y cubed is x minus 2. Is that okay? So it's kind of like I'm moving it across. When it moves, it changes sign. But you know, really, it's a -2 on both sides. Okay, then how do I get rid of the cubed? Cube root it, yep. Now, one thing that's important, or it'll be more important tomorrow, but do you remember when you square root, you had to pick the plus or the minus? Okay, cube roots, you don't have to do that. Okay, so lucky us. So then, these guys cross out, y equals cubic root x minus 2. Okay, -2 is on the inside. Which way will I shift? To the right 2. Very good. So on my graph, I'm going to go to the right 2. That'd be right here. What ordered pair is that? 2, 0. And then look, they're partners. They're backwards. Okay, that's what we want. And then from there, this is a cubic root. So remember, you put your dot, you go up, and then down. So I'm going to go up on this side, and then down on that side. Okay, and they're the same shape. They're just reflected across the diagonal from each other. Okay? Good? Okay, one more like that. Look at number 4. This time I want you to notice in the very front, what do we have on this one? A negative. So instead of going up, it's going to go down. Okay, good. So negative is important. What's our start point? Positive 3, 7. Very good. So 3, 7 is here. And then don't draw it going uphill. It needs to be drawn going downhill. So when I draw it, the right side goes down. The left side is going to curve up. Okay, and then I'm going to put a little star here and put reflect across x-axis. Okay, bless you. And that's because of the minus in the front. Now, I want to point something out to you real quick. This might not really make that much sense, but if I took this original graph, okay, pretend like it's the original one, and I flipped it backwards, would it look different? Okay, hold on. Let me go back to here, to the original one. Okay, don't do this, but this is like from yesterday's homework. If I flipped this, I'm going to flip this one backwards, and I'm going to do this one down. Okay, if I flipped it down, it would look like that, right? What about if I flipped it backwards? What do you notice? The graphs are the same. That's a characteristic of that rotational symmetry. So the other cool thing, or not cool, but the other like less extra thing is for these, it doesn't matter if you flip it down or backwards. It's going to look the same either way. Okay, so remember for square roots, you had to think about, am I flipping it down or backwards? Okay, these, you don't have to worry about that. Okay? Yeah, so it's going to look the same either way. Okay, from here, let's find our inverse. So I'm going to do both of the switch steps in one. So I'm going to write this side first with the y. And then I'm going to put the equals x second. Okay, so in that problem, I switch the letters and the sides at the same time, just since we're doing so much of it, so we don't have to write as much. Okay, subtract the 7 is correct. Okay, so minus 7, now it's an x minus 7. Okay, now on the left side, we have a minus in the front. We want to get rid of it. The way that you're going to get rid of the minus 1 is by multiplying by another minus 1. This is why. What happens when you do a minus 1 times another minus 1? They're going to cancel out. They're going to be positive. Now, if I'm going to put a minus 1 on this side, I have to put a minus 1 here, and I want you to group this in parentheses but you are not going to distribute. Okay, the reason why is because when you're graphing, you want to have the x with the minus 7. So, I guess I should write do not distribute. Okay? So, these guys still cross out. So, now it's just a y minus 3 inside parentheses cubed. And now it's a negative 1 x minus 7. Okay, what do I do from here? Cubic root and cubic root. Okay, and then I don't know if you guys remember this too, but remember how you're not allowed to take the square root of negatives? You're allowed to take the cubic root of negatives. That doesn't matter. So these guys cross out. Y minus 3 is left over. On the inside, I have a negative and then an x minus 7. You can put the 1 or not put the 1, it doesn't matter. And then how do I get rid of the minus 3? Plus 3 and plus 3. So it's y equals cubic root negative x minus 7 plus 3. Now, remember what we just talked about. When I draw my graph, does it matter that my negative's on the inside? It's going to look the same either way. For square roots, it matters because it could determine whether it flips down or backwards. But for these, nobody cares. So my start point will be what? 7, 3. Because remember, if it's a minus 7 in the parentheses, then it's really a positive 7. So I'm going to come over here to 7, 3. And then instead of doing my little squiggle going uphill, I have to do it going downhill. So it's going to look like this. I'm going to go, normally it's like this. So I'm going to go like this, and then like that. And notice that it's going downhill because it has a negative on it. So this branch curves down, this branch curves backwards and up. Okay? And then you see you have that symmetry. That's just a double check to make sure that it's right. Okay? Alright, go to the last page, please. Okay, the last page, we're not going to do all 4 of these. Actually, before we do that, read through that bottom think about it question. 2 of those are true. Circle the 2 that are true. I'll give you a second to think about it. There are 2 that are true and 2 that are false. And it doesn't even really matter the equation they give you. We're talking just about inverses. So statement 1, the domain of f is the same as the range of the inverse. True or false? True. Okay, the domain always matches the range of the inverse, right? That's always true. Okay, look at the second one. It says the x-intercept for each function is the same. That is false. Now, if you would like an example of that, here's how you know. Let's say the x-intercept was 2, 0. What would that be for the other equation? 0, 2. Is that an x-intercept now? That would turn into a y-intercept. Okay, so remember that that's not true. When I reverse those points, x-intercepts are going to flip to be y-intercepts, and y's will flip to be x's. So that's not true. Okay, look at number 3. F and F inverse have 180-degree rotational symmetry. True. Okay? And then the last one says that they never intersect. False. Now, if you want an easy proof of that, just look on the page we just did, right? Did they cross? Did this one cross? So then saying they never cross, that's obviously wrong. Okay, we're not going to do all 4 of these, but let's take a look at, we'll start with number 5. Okay, you're doing inverses, so we're switching the letters and switching the signs. I'm going to do this side first. So it'll be 1/3 y plus 1 cubed plus 4 equal to x. So I'm switching the sides and the letters at the same time now. Okay, it does have a fraction in it. Okay, but we can still solve it, just like we solved the other ones. What would my first step be? Minus the 4. So now I have x minus 4. Leave a little bit of space right here if you haven't already written it. Okay, then on the other side, these cross out. I have 1/3 y plus 1 cubed. Okay, I cannot cubic root because I have a number on the outside still. Okay, 1/3 is the same as a divide by 3. How do you cancel out divide by 3? Multiply by 3. So look, I'm going to put a multiply by 3 here.
Times 3.
And on the other one, you're going to put parentheses, and you're going to still not distribute. So remember what we said with negatives? That's true for numbers too. I'm going to keep that 3 separate, and I'm going to just group the x minus 4 in parentheses. Okay, then from there I have this, y plus 1 cubed. What do I get rid of next? The cube, and how do I do that? By taking the cube root. So I'll do the 3 root here, 3 root here. And notice that since that 3 was kind of over here chilling, okay, it's inside the house now. So these guys cross out. I have y plus 1, cubic root, 3x minus 4, and then what do I do with this plus 1? Okay, I'm going to just move it across as a minus 1, so my answer will be this. Cubic root, 3x minus 4, and then a minus 1. Okay, and remember it switches to be a minus 1 because it's going to the other side. Okay? And then one more thing I want to point out to you. Do you remember? I'm sorry? Oh, it should be outside. Thank you. It should be at the back. Now, do you remember when we talked about stretches and compressions? Okay, what type is 3 if it's inside the root? If it's inside the root, remember it switches it. So normally 3 would be a stretch, but it's a compression. Because if it's inside, it switches up the rules. Okay? Alright, go down to number 3. Start this one off for me. I'm going to start with this side. So it's a negative 1/2 this time. We're going to see how this looks different. Okay, so it's a negative 1/2 y minus 7 cubed plus 5 equals x. Okay, first step is to get rid of the plus 5. How do we do it? Okay, minus 5 on both sides. So now on that side I have x minus 5. Leave a little bit of space in front of it. Okay, now you have 2 choices here. You can do it in 2 steps, or you can do it in 1 step. I'm going to do it in 1. How do I get rid of the negative? I times by another negative, right? So put a negative here and a negative here. How do I get rid of a 1/2, which is a divide by 2? Multiply by 2. So I'm going to times by negative 2 and negative 2. And then on the right side, I don't want to have to distribute, so I'm going to keep parentheses. So these guys both cross out with each other. The negatives take each other out. The 1/2 and the 2 take each other out. And now I just have the y minus 7 cubed, and I can keep solving. So it's a negative 2 in the front. And then an x minus 5. And then from there, what will I do? Cubic root and cubic root. And notice that that negative 2 ends up on the inside of the root. Okay, these guys cross out. And then how will I get rid of the minus 7? Okay, plus 7 here and plus 7 here. So my answer, you're just going to write it in the blank, would be the cubic root of negative 2x minus 5, and then plus 7, and then just like last time I made my square root a little too long, but your 7 shouldn't be inside. Okay, now, is that one going to be a stretch or compression? It's a compression because where's the 2? On the inside. Now, does it matter that the negative's inside?
No.
It's going to look exactly the same. Okay? Alright, last one that we're going to do is number 2. This time, instead of having a fraction in the front, you have a whole number in the front. So, I'm going to make it 3 y minus 4 cubed minus 2 equals x. So, step 1, you switch the letters, switch the sides. Then drop your railroad tracks. What's the first step? Okay, plus 2 on both sides. Okay. So now I have x plus 2 on the right side. Ooh, I should have left a little bit of space, but I didn't. Okay, now I have a 3 y minus 4 cubed. Okay, to get rid of a fraction, you have to times. So to get rid of a times, I'm going to have to put a fraction. If it's a 3, what fraction will cross out with that? 3 and what? Look over here. 3 and 1/3, right? Those cross out with each other because a 1/3 is really a divide by 3. So on both sides, you're going to put a 1/3 here so that those guys can cross out. And then on this side, you're going to put a 1/3, but you're going to put parentheses because remember, you don't want to distribute. My 1/3 and my 3 cross out with each other. I have a y minus 4 cubed left over. 1/3 stays on the outside. And then I'm going to cubic root. And then what will my step be after that? I'll take my positive 4 across. So those guys cross out. I have y minus 4 left over. And then for my very last step, I'm going to add that 4 plus 4 plus 4. And that would be your answer. Okay, now look at this one carefully. Normally a third means a compression. What does it mean for this one? A stretch. Because since it's on the inside, okay, it changes its job. Now, I want to point out one other thing to you before you start working on your homework. Okay, do you notice that on all of the problems, okay, that we did on this page, none of your numbers really disappeared. They just ended up in a different spot. So this is what I mean by that. Okay, like look at this one. I had a minus 4. What did my answer have in it? A plus 4. Where was my minus 4? On the inside? Where did it end up?
On the outside.
Okay, my minus 2 is on the outside. Now I have a plus 2 on the inside. I had a 3. Now I have a 1/3. So none of those numbers should be just magically going away. Same thing on this one. I had a plus 4 on the outside. Where did it end up? Minus 4 on the inside. I had a plus 1. Now I have a minus 1. I had a 1/3. Now I have a 3. So those numbers shouldn't really be disappearing. They should just be like moving around. Okay? All right. There's one on your homework that's kind of hard. It's the very last one. So, do you want to do it together? Okay, homework 7, number 8. Okay, do your first step for me on number 8. Okay, so we're going to switch the letters, switch the sides. So it'll be 1/2 3 y minus 5 plus 4 equals x. So step 1, you switch the letters, switch the signs, or the sides. What will I do first? Okay, minus the 4, that's correct. So I'm going to minus 4 here, minus 4 here. These guys cross out. Okay. Yep. Okay, so look next. I have 1/2 3 y minus 5. Leave a little bit of space. X minus 4. How do I get rid of a half? I times by what? 2. So I'm going to times by 2 here to cross it out. Here, put parentheses. Okay, now from here, can I, as my next step, divide by 3? Okay, answer is no. This is why. Is that inside or outside? It's inside. So what do I have to do first to get rid of the cubed? You have to cube root next. Okay? So I'm going to cubic root here, and I'm going to cubic root here. And so the reason why is that this 3 is inside the cubed parentheses. So that's why you can't really touch it right off the bat. Okay, so from there, my cube root and my cubed cross out with each other. So now I just have 3y minus 5. Cubic root 2x minus 4. Okay, then how do I get rid of the 3 in the front? Because remember, we don't want to distribute. Not 1/2, 1/3. So I'm going to put a 1/3 here and a 1/3 here. So then these guys cross out. Now it's just a y minus 5 left over. How do I get rid of the minus 5? How? Add it, yep. Okay, so that one's kind of long. The other ones aren't that long. But as my last step, I would take this minus 5 and I would plus it in the back. So notice that it is possible for you to have a number on the inside and a number on the outside. But look at the thing we were talking about before. I had a 1/2 on the outside. Now I have a 2 on the inside. I had a 3 on the inside. Now I have a 1/3 on the outside. So all those numbers are still there. They're just scrambled around. Okay? All right. Go back to number 1 for me on your homework. What should your symmetry point be on number 1 for the middle of the table? Good. Okay, so when you type that into your calculator, make sure you put your start point in the middle. So if I'm looking at these two, -7, -1 is here. And then just like we did on the first example, you're going to punch that into your calculator. You guys all got calculators? Okay, you're going to punch that into your y equals. So I want x plus 7 up to the 3 and then minus 1. And now look, I can even graph it to see the picture. Okay, it moved backwards 7 and down 1, then second table. And I'm going to have to scroll to get the 2 points above it and the 2 points below it. So what's right above -7, 1? -8, -2. Okay, then right above that, what comes next? -9, -9. Okay, what's the next one below -7? -6, 0, and then -5, 7. Okay, but if you try to use 0, then it ends up being like, goes with like a 342. Obviously that won't fit on your graph. So that's why we want to pick the ones that will fit. Okay? Then you're going to graph it. So -8, -2 is here. -9, -9 is way down here. -6, 0 is here. And then -5, 7 is here. And when you connect your dots, you should see that same shape that all the other ones had. And then when you do the inverse, it should be like a sideways squiggle. Okay? What are your domain and range going to be for both of these? Okay? I'm just going to put big IRs, okay? Because remember, for these, they're always all real numbers. And so when you switch it, it'll be 7, -5. Okay?